Thank you guys for joining me today. I will start with this module, which is a little bit introduction for rigid body equilibrium in 2 dimension and the 3 dimension also. So I will talk about moment of a force and distributed loads in this meeting today. Keep in your mind that the meaning of moment, we have a force and we have distance. If you multiply this force by this distance, you can get a moment. But your force and your distance must be perpendicular. So how this force would like to rotate this arm around point O. So this is the tendency to rotate is called torque, but commonly we are saying moment. So your moment of a force around a point equal this force time this distance. But keep in your mind, your force and your distance must be perpendicular. Your force and your distance must be perpendicular to create a moment. And we can say the larger force you have or the longer distance you have means you have greater moment. If your force is bigger, your moment will be bigger. Or if your distance is longer, your moment will be bigger. So the larger the force or the longer the moment arm. By the way, this distance can be called moment arm. It's not a big deal, but keep it in your mind. Moment arm. So the bigger or the larger force or the longer moment arm means the greater the moment you have. So if you have a nut at this location and you would like to rotate it, but it's very tight, okay, and you have a limit force with your hand, okay, go ahead and use longer wrench. That makes sense? If you cannot increase the applied force, go ahead and increase the arm, the moment arm, make it longer. So you can create more moment or greater moment so you can rotate this nut. That makes sense? Any question so far? So to summarize this slide, we have something called moment. This moment is coming from a force and a distance. Your distance between the force and a certain point, because you are calculating the moment at a point. I have to tell you where is the point. Keep in your mind, if you have a force and we don't have point, that means we don't have distance. That means we don't have moment. So you have a force and you have a point and you have distance between the point and the force, and keep in your mind this distance must be perpendicular to the force. So we have 3 parts: force, distance, point. Point, distance, and force. And keep in your mind the distance is the distance between, or the arm between the point and your force, and both of them are perpendicular. Let's do an example here. We have a force 100 Newton at this point, and we have a point O. Can you tell me what is the moment of this force around point O? What is the force? What is the value of moment for this force about point O? So your moment O equal your force 100 times your distance 2 meters. Here is point O. Here is your force 100. Here is the distance in between, but keep in your mind this distance is perpendicular to the force. This is a very important condition. Without this condition, you are not calculating a moment. You are calculating something else, different value, wrong value. And keep in your mind, if you stand at point O and here is your force 100, this force by this arm would like to rotate clockwise. So the value or the moment value equal to 100 Newton meter. Because this force in Newton, this distance in meters. So the unit of your moment will be Newton meter. The value of the moment is 200. The direction of the moment clockwise. Direction means this force would like. This force intends to rotate around point O clockwise. That makes sense? Anybody has any question? One more example. We are given this beam and we are given a force 50 Newton, and we would like to calculate how much moment this force will create about point O. So your moment equal force time distance. Your force is 50 Newton. Anybody in this meeting can tell me what will be the distance between this force and the point O? Any help? Guys, any help? Anybody can tell me what will be the distance? 0.75, that's correct. If you multiply 50 by 2 meters, that's wrong. This is not a moment because the direction of your force, which is horizontal, and the direction of your distance, which is horizontal, both of them in the same direction, does not work. Your force must be multiplied by a distance perpendicular to each other. So the distance between the force and your point vertically is 0.75. So in the first example, your force was vertical, your distance was horizontal. In the second example, your force is horizontal, your distance is perpendicular. Not any vertical distance, but the distance between the force and this point in a vertical direction. That means your moment value will be 50 times 0.75 equal 37.5 Newton meter. And if you imagine how this force would like to rotate around point A, rotate means the force would like to create a circle. It will rotate in this way, which is clockwise direction. One more example. We are given this beam and we are given a force 40 pounds vertically, and we have point O, and we would like to calculate how much moment this force will create about point O. Your force, your moment equal force time distance. The force we have is 40. What is the distance? Is it 2 feet? Is it 4 feet? Is it 6 feet? Or what? The distance between your force, keep in your mind, your force in a vertical direction, like this. So your distance must be horizontal, like this, to be able to multiply both of them to create your moment. So I think your distance will be 4 feet plus the horizontal distance here, which is 2 cosine 30. Do you agree? So the horizontal distance is not 6. 2, this is the inclined distance. I cannot add this distance plus this distance. No way, you are kidding. So the horizontal distance for this part is 2 cosine plus 4 times 40. Your final answer will be 229.3 pound foot. Your force in pound, your distance in feet, your final unit of your moment, pound foot. And I believe this force direction would like to rotate in this direction. Just leave this force to move and rotate. If this force moved and rotated, it will move and rotate clockwise direction. Any question so far? A force time distance, but your force and your distance must be perpendicular. Keep in your mind, if we have many forces, like F1, F2, F3, if we have many forces, and we have point O, we can get the resultant moment. Resultant moment means each force times its distance, each force times its distance, each force times its distance. So your resultant moment equals summation for each force times its distance. I mean, F1 will be multiplied by its distance. F2 will be multiplied by its distance. F3 will be multiplied by its distance, but take care of the sign, because the force F1, for example, would like to rotate this way. F2 would like to rotate this way. F3 would like to rotate this way. I cannot add them together, but one of them will be positive and the other one will be negative. So we can assume the counterclockwise is my positive. It's up to you. Counterclockwise means this direction is positive. That means the counterclockwise is positive. That means the clockwise rotation will be negative. Does that make sense? So if you assumed, you can change this assumption, that's fine. If you assume the counterclockwise rotation is positive, that means the clockwise moment will be negative. So the resultant moment will be something like this: F1 times D1, F2 times D2, F3 times D3. The clockwise will be, the counterclockwise will be positive and the clockwise will be negative. So the final answer will be called the resultant moment. This is the case if you have many forces. But keep in your mind, your force and your distance must be perpendicular. Your force and your distance must be perpendicular. Your force and your distance must be perpendicular. Any question? Guys, do you have any question? I have one more example. This example. We are given this beam with many forces: 50 Newton, 60 Newton, 40 Newton. And I would like to get the resultant moment for these three forces, or I'm sorry, I forget 20. For these four forces about point O, what is the moment, the value of the resultant moment of these forces about point O? Moment resultant about O equal summation for each force time its distance. Each force time its distance. let's try. Let's try with the first force, 50. Anybody in this meeting can tell me what is the distance between 50 and the point O? First of all, your 50 is vertical. That means your distance must be horizontal. What is the horizontal distance between 50 and the point O? How much? How much? I need one to answer this question. What is the horizontal distance? Thank you. It's 2 meters. I think the 50 times 2 would like to rotate this way. If you leave 50 to move and rotate, it will move and rotate in this way. So I will assume this direction is my positive. That's fine. It's up to you. I assume the clockwise is positive. That means any counterclockwise will be negative. You are right. So this one is positive. Next force. I have 60. Be careful before answering this question. Anybody can help me? What is the distance between this 60 Newton force and your point O? Anybody can tell me what is the distance between the force 60 and the point O? Great work. Thank you, David. Yes. 0. I have a name here called surface. Who is this? I think you are Ivan. Okay, thank you. It's 0. Hey, I cannot multiply 60 by 4 because 4 meters in the same direction of the 60. We cannot create a moment between a force and the dimension in the same direction. So the question is, since your force is horizontal, your distance must be vertical. So the question is, what is the vertical distance between the location of your force and the location of point O? Do you have vertical distance between the 2 points? No. So it's 0. I don't care about it's positive or negative because your moment is 0. Okay, which one is next? Let's talk about force 20. Since your 20 is horizontal, your distance will be vertical. So what will be the vertical distance between force 20 and the point O? Keep in your mind the inclined distance here for this part is 3 meters. And this angle is given 30. This angle is given 30. So I can figure out the vertical distance and the horizontal distance by this 30 and 3 meters. The horizontal one will be 3 cosine 30, and the vertical one will be 3 sine 30. Does that make sense? If you look here, this 3 meters is inclined. I can convert this 3 meters to horizontal distance and the vertical distance. So what will be the vertical distance between 20 Newton and your point O? The vertical this distance will be 3 sine 30, which is the vertical distance here. Does that make sense? And your distance and your force are perpendicular. We are good. The second question, If you leave the force 20 to move and rotate, if this 20 would like to move at the same time rotate around point O, I think it will move and rotate this way because the force is going to right. So let the force move at the same time rotate about point O to make a circle about point O. It will make a circle like this. So it will be counterclockwise, which is negative. We still have one more. Which is the vertical force 40. Since 40 is a vertical force, I'm looking for the horizontal distance between the force and the point O. This horizontal distance equal 4 meter plus 3 cosine 30. This little 4 meter and this horizontal distance, which is 3 cosine 30. I believe if you left this 40 to move first and then rotate, it will move and rotate this way. Will move down and then rotate to create a circle around point O. It will be clockwise, so it will be positive. Does that make sense? So I can figure out the final resultant moment will be 50 times 2 plus 0 minus 20 times 3 times sine 30 plus 40 times 4 plus 3 times cosine 30. Your final answer will be 333.9, and your unit will be Newton meter, because you are multiplying force time distance. So the unit of the final moment will be Newton meter. Any questions so far? So what we covered so far, we have a concept called the moment equal force time distance. I'm talking about a moment in 2 dimensions, xy. So you have a force, you have distance, your force and your distance are perpendicular, you have a moment. Your moment equal force time distance, and you have to tell me how this force would like to rotate about this point, clockwise or counterclockwise. Because if we have many forces and you need to figure out the resultant moment, we have to multiply each force times its distance, each force times its distance, each force times its distance, and we need to determine which one is positive and which one is negative. It's up to you. If you assume clockwise is your positive direction, so the counterclockwise will be negative. If you assume the clockwise is your negative direction, the counterclockwise will be your positive. This one will give you the final answer. This one will give you also the final answer. Does that make sense? So I don't care which one is the positive and which one is the negative. But if you assume this one, so keep in your mind all forces rotating clockwise will be positive, and any other force will be negative. That makes sense? And we have examples here for single force times its distance, you can get a moment. Single force times its distance, you can get a moment. Single force times its distance, you can get your moment. If we have many forces, like this one, like this one, like this one, and this one, so each force times its distance. Sometimes you have a force and you don't have distance. That's fine, no problem. Don't worry. But keep in your mind, your force and your distance must be perpendicular. We have one more example. We are given in this problem a point O and a force 400 Newton. And we would like to figure out the moment of this force about or around point O. Unfortunately, if you try to figure out what is the distance between the force and the point O, and this distance perpendicular to the force, you will not find any distance. No way. No way. This distance is not perpendicular to the force. This distance is not perpendicular to the force. This distance is not perpendicular to the force. I'm trying. You can extend something like this and you draw a perpendicular. You are kidding. How can I figure out these dimensions? No way. In this case, what should I do? Very simple. And this is common. Keep in your mind, this is common. We don't like inclined force. What you mean by inclined? This force 400, is it horizontal? No. Is it vertical? No. So I need to break this force first to two components, one horizontal and one vertical. We learned this in the first module of this course, how to break a force to two components. So the component adjacent to the given angle 30 will be cosine. So we have 400 cosine 30. And we have 400 sine 30. So right now, I break this force to two. 400 times cosine 30 give me a value here, 346.4. And I have a component here equal to 200 Newton. So instead of having one force, right now I have two forces, one horizontal and one vertical. Go ahead and define the resultant moment about point O. Equal summation of each force times its distance. Let's start. Let's start. The first force, 200. This force, 200. What is the distance between 200 and the point O? Since 200 is a horizontal force, I have to measure the distance in a vertical direction. It will be 0.2. Your distance and your force are perpendicular. We are good. We are good. I will assume the clockwise is positive, so the counterclockwise will be negative. Let me ask you a question. This force 200, if you leave it to move and rotate to create a circle, I think it will move and rotate like this. Because the forces would like to move to right and then rotate, so it will rotate counterclockwise, so this direction will be negative. The next force, 346.4. This force in a vertical direction. So your distance must be horizontal. What is the horizontal distance between this location and this location? The horizontal distance between the two positions is 0.4. So your distance and your force are perpendicular. We are good. If you leave this force to move down and rotate, moving down and rotate, so it will move down and rotate, so it will move clockwise. It will be positive. Do you have more forces? No, we have only two components. I am done with both of them. So the final resultant moment will be negative 200 times 0.2 plus 346.4 times 0.4. I got 90 positive, 98.56. Anybody in this room can tell me what is the direction of this resultant moment? What do you think? This resultant moment will be clockwise or counterclockwise? Any answer? This final moment, this resultant moment will be clockwise or counterclockwise? Thank you. Since your value is positive, so thank you. Since your value, the final value from this calculation is positive, that means your direction of the resultant moment will be positive. That makes sense? If your final value of the resultant moment is negative based on the calculation, that means the direction of this moment will follow this direction, which is counterclockwise. That makes sense? So keep in your mind, if you have a force inclined like this one, and we have a point here, the best scenario to get the moment of this force about this point to break this force to two components, one horizontal and one vertical. Because the horizontal component, you can figure out the distance between this location and this location, vertical distance. The vertical component, you can figure out the horizontal distance between this location and this location. Does that make sense? So if you have any inclined force, the best scenario is to break this force to two components, one horizontal and one vertical, so your moment, resultant moment will be very easy to get it. But if all of forces are vertical and horizontal, you are lucky. Go ahead and find the force and the distance, and that's it. So far, so good. I was talking about 2 dimensions, which means X and Y, nothing else. But if we are in 3 dimensions, what you mean by 3 dimensions? I mean we have X, Y, and Z. And here is a force in 3 dimensions. And we have a point here, O. And we would like to get the moment of this force about point O. It's in 3 dimensions. So what should I do? We have, this is force in 3D. We have this equation. The moment of a force about point O in 3 dimensions equal R cross product. This is not time, because this is not a value. This is a vector. And this force is not a value, one value, it's a vector. Vector means we have number I plus number J plus number K. And this vector R is number I plus number J plus number K. And you are multiplying 2 vectors. We cannot say time. We have to determine what type of multiplication. It's a cross product. Cross product. How to figure out this cross product? I will figure this out. Don't worry. But so far, if we have a force in 3 dimensions and a point, and we would like to figure out what is the value of moment of this force about point O, we need to multiply 2 vectors. The first vector is called position vector. This position vector between the point to any point on the force. The R represents a position vector directed from point O to any point on the force. And the second vector is the vector of the force. If you multiply both of them cross product, you can find your final moment as a vector. Wow. What? The final moment in this case is not just one value. No, it will be a vector. Number I plus number J plus number K. So your final moment for this force about this point will be a vector also. Does that make sense? Keep in your mind, don't worry, don't worry. If we have a point here and we have a point here, this point is, for example, 4, 6, 8. And this point, for example, is -3, -4, and 10. And we have a vector between this point to this point, R. So the vector R can be determined like this. Your vector R, position vector, equal. Since this vector is going from this point O to this point A, for example, so coordinates of point A minus O. So it will be -3 minus 4i plus -4 minus 6j plus 10 minus 8k. So the position vector will be -7i, -10j, and plus 2k. That makes sense? It's very easy. Very easy. Just to tell me what are the coordinates of the 2 points. So I can subtract the coordinates of the second point minus the coordinate of the first point to give you the position vector. This is R. Keep in your mind this R between the point where you are taking a moment about to any point on the force. If you can figure out the coordinate of this point and the coordinate of the second point, just multiply the second point minus the first point. I can tell you the the vector R, the position vector R. And we learned in module number 3 and 4 how to create a force as a vector. How to break this force to 3 components if it's not given in 3 dimension as a vector. That makes sense? How to make cross product between a vector and another vector, I need to remind you for something you learned in math. So assume A is a vector, B is a vector. So A is a vector, we have number I plus another number J plus another number K. So this one will be, for example, AX, AY, AZ. So go ahead and put the 3 values here in the second row. And the B will be a number I plus another number J plus another number K. Assume they are BX, BY, BZ. We will have numbers. So I will put them in the third row. And the first row will be I, J, K. And I will find what is the value of this determinant. Do you remember how can we figure this out? Go back to your math and find your value. So the first, your final value, the final cross product will be a vector. To find out the first term, we need to do this. I will cancel the first column and the first row, and I will multiply this one times this one minus this one times this one. You can give you the first term. Thank you. And the second one, yeah, this one. Should be negative. The second one, I will cancel this column and this row. So I will multiply this value by this value minus this value minus this value to give you this term. If you would like to figure out the third term, I need to cancel this column and this column for the K and multiply this one by this one minus this one times this one, so you can get the third term. So what we learned so far, that if you have a force in 3 dimensions and you would like to figure out the moment of this force about this point, we need to do cross product. between a position vector called R, this position vector between the point O that you would like to create a moment about, and any point on the force. How to figure out the value of this vector, position vector? It's very easy. Just tell me what are the coordinates of the 2 points. Then subtract the coordinate of the second point minus the first point can give you the position vector of this R. Then your force will be in a vector format. That means you should have 3 components. How to do the cross product? I, J, K, the first row. The second row are the numbers of the position vector R. The third row are the numbers or the component of the force F. How to do your cross product? Keep in your mind the final answer for your moment. It will not be one value. It will be a vector, I, J, K. To figure out the first term, I need to cancel the first column and the first row. So I can multiply this one by this one times this one minus this one times this one. The second term will be negative. I have to put negative here for J. Go ahead and cancel this column and this column and this row. This one times this one minus, I'm sorry, this one times this one minus this one times this one. You can give you the second term. The third term, I have to cancel the third column and the first row. So I can multiply this one times this one minus this one times this one. I can get the third term. That makes sense? So your value of the moment will be a vector, not just a one value. Let's do an example. Let's do an example and see how to figure out the moment of this force, 2 kilonewton, around point O in 3 dimensions. We have a big issue here. The first issue, what is the force in a vector format? Unfortunately, the force is given just 2 kilonewton. But I don't know what is the vector value of this force. What are the 3 components of this force? So I need to go back to module number 4 that we covered last week. Your force F as a vector equals the force F 2 kilonewton as a value time. Keep in your mind, this force is going from A to B. Okay, let's start to figure out the coordinates of the 2 points. What are the coordinates of point B? Let's start. This is your origin, 0, 0, 0. If you would like to move from the origin to point B, I think I will move in X 4. In Y 12, in Z 0. So the coordinates of point B will be 4, 12, 0. The coordinates of point A will be in X 0, in Y 0, in Z 12. If you have any question, let me know about these coordinates. As we learned before, if you would like to figure out the coordinates, you have to move from the origin to the point. So how did you move in X? How did you move in Y? How did you move in Z? Now I can do the math to convert your force to a vector. Since the force is going from A to B, so B minus A. 4 minus 0 I plus 12 minus 0 J plus 0 minus 12 K divided by 4 square plus 12 square plus 12 square. So your force as a vector will be, the denominator is 16 plus 144 plus 144 under square root. This value, the denominator equal 17.4. This one will be 4, this one will be 12, this one will be negative 12. So the final answer, 2 times 4 divide 17.4, I got 0.5 plus 2 times 12 divide 17.4, I got 1.4 J. Then negative 2 times 12 divide 17.4, I got 1.4 K. So the first step, I converted my force to a vector format. R, which is called the position vector, must be between point O and any point on the force. It's up to you. It's up to you. It's up to you. So I think I will choose R, the vector R, the position vector between O, A. This vector works. OA. I'm sorry, OB. I'm sorry, OB. Because your point B is already on the line of the force. Or you can select R, position vector between O and A. This line vector or this position vector, that's right. Correct also, OA or OB. Both of them works. Because point A already on the line of the force, point B already on the line of the force. So the position vector between the point O that you are looking to get the moment about and any point on the force, it's up to you. It's up to you. So let's select ROA. ROA as a vector, the vector is going from the point O to point A. Must go from the point that you are looking to get the moment to any point on the force. So the coordinates of point A minus O, it will be 0 minus 0I, 0 minus 0J, 12 minus 0K. Does that make sense? So this one works. So your moment about point O will equal, I will open the determinant. I have I, J, K. The first row is the numbers of your position vector, 0, 0, 12. The next row will be the values of your forces. 0.5, 1.4, negative 1.4. Then let's start. Let's start. To get the value of I will cancel the first row as the first column and the first row. Then I will multiply 0 by negative 1.4 minus 12 by 1.4. So it will be negative 16.8. That makes sense? The second term for J, I have to put negative here. I have to put negative from my side and wait for the value sign. So I will, in this case, I will remove this column and this row. So I have 0 times negative 1.4 minus 12 times 0.6. It will be negative 6. And we have negative, so it will be positive 6. That makes sense? So this one, I put this sign. You have to put negative for the J term. And this value is coming from calculation. I multiplied this one times this one, minus this one times this one. I got negative 6. And we have negative, so the final will be positive. And we have plus the value for K. If you would like to figure out the value for K, I have to remove this column and this row. So 0 times 1.4 minus 0 times 1.5, it will be 0. So the final value for your moment equal negative 16.8 I positive 6J plus 0K. This is your final answer. So what we learned so far, if you have a force in 3 dimensions and you would like to get the moment of this force about point O in 3 dimensions, you have to get this force in a vector. And you have to get another vector, it's called position vector, between the point of rotation, the point of the moment O, and any point on the force. Then you need to do cross product. How? I will set up a determinant. The first row IJK, the second row the numbers or the terms for the position vector. The third row will be the terms for your force in 3D, the 3 component. Then I can figure out the final value as a vector, I, J, and K. In the solved examples, we did, I'm sorry, just a moment. Oh, we lost everything. Anyway, we did in the solved examples, first step, I converted this force to 3D, to a vector. What we learned in module number 4. Then I choose a position vector between the point O and any point on the force. So I selected A. Between O and A. This is the direction. So the coordinates of point A minus O. I found it. Then to find out the moment, I set up this determinant, I, JK, and then I put the 3 terms for the position vector and the 3 terms for the force. Then I found the value as a vector. Like we did here. We lost everything also. Does that make sense? Okay. If you have many forces, F1, F2, F3, F4, F5 in 3D, and we are looking to get the resultant moment of these forces about 1.0, we have to do what we did for each one. So for example, I will work with F1 and R1 to get the moment. And then for F2 and R2 to get the moment. And F3 and R3 to get the moment and add them together. Does that make sense? Let's do one more example and that's it for today. We are lucky in this problem because F1 is given in a vector format. So you don't need to break your force to 3 components. And the F2 is already given in a vector format. We are lucky. So we have point O and we need to figure out the resultant moment of these 2 forces about point O. So let's start for MO1. MO1 for F1. So it will equal R1 times cross product F1. MO2 will equal R2 times cross product F2. Then I will add MO1 plus MO2. Let's see. R1, I need to figure out R1. R1 is a position vector between the point O and any point on force F1. I think I will select O. So this is your R1. The coordinates of point O is 0, 0, 0, based on the X, Y, Z axis. The coordinates of point A is in x0, in y5, in z0. Do you agree? If you don't, let me know. This point O, if you would like to move from the origin to this point in x0, in y5, in z, it will be 0. So the position vector between O and A will be 0, I, 5, J, and 0, K. Coordinates of point B, of point A minus O. 0 minus 0, 5 minus 0, 0 minus 0. And if 1 as a vector is given, you are lucky, negative 60i, positive 40j, positive 20k. So I can set up this determinant. I, j, k, 0, 5, 0, negative 60, 40, 20. Equal. I think you can do it directly. So if you cancel this column by this row, I will have 5 times 20 minus 0 times 40. It will be 100 I minus. If you would like to figure out the J term, I will cancel this column by this row. So this one times this one minus this one times this one, it will be 0 J. The third term, if you would like to, I would cancel this column by this row, this one times this one minus this one times this one, it will be positive 300K. This is the moment of F1 about O. Let me review it. If you cancel this column by this row, I have 5 times 20 minus this one times this one, it will be 100. If you cancel this one, it will be 0. If you cancel this one and this one, it will be 0 minus 5 times 60, it will be 300. We are good. Let's repeat this one more time with force F2. R2 is a position vector between the point O and any point on this force. I will select B. So this is your R2. To figure out this vector, I need to figure out the coordinates of point B. What are the coordinates of point B? If you would like to move from the origin to point B, I will move in X4. If you would like to move from the origin to point B, I will move in Y5. If you would like to move from the origin to point B, I will move in Z -2. Does that make sense? So the position vector between O to B will be coordinates of point B minus O. It will be 4i. It will be positive 5j. It will be negative 2k. And your force F2 is given. You are lucky. We are not looking for F2 as a vector. It's a given. 80i plus 40j minus 30k. So your moment of the second force about O will equal this determinant. I, J, K, 4, 5, -2, 80, 40, -30. Let's start. What is the term for I? I will cancel this one by this one. So I have 5 times -30 minus -2 times 40. I got -70. Minus. This minus from me. And I will cancel this column by this column. So I have 44 times -30 minus -2 times 80. I got 40 positive, and we have negative, so it will be -40 J. For the K term, we have positive here, should be. I will cancel this column by this column, so I have 4 times 40 minus 5 times 80. I got negative 240. So your final moment, the resultant moment, for both of them, this force and this force, I have to add this term or this vector plus this vector. Just add the I term plus I term. It will be positive 30I. The J term plus J term, it will be negative 40J. The Z term plus Z term, it will be positive 60K. This is your resultant moment. Does that make sense? Easy. I know it's a little more calculation, more math, but it's very easy. If you have many forces, just to go ahead and define the moment for each force around point O. The moment for this force about point O. Then you have a vector. You have another vector for the two moments. Add them together to get the final resultant moment for all of them. So what we covered today, we covered how to figure out a moment from a force and the distance. It's very easy in 2 dimensions. You need only just to multiply your force by your distance, but make sure the force and the distance are perpendicular. For the 3 dimension, we need to do a cross product between a position vector and your force as a vector. The position vector is a position vector between or directed from the point that we are calculating moment about and any point on the force. How to do the cross product? We need to set up this determinant and put the first row ijk, the second row the 3 terms for the position vector, and the third row is the 3 terms for your force. Then the final value will be a vector, not just a one value, just a vector. If you have many forces, I need to do this many times for each force and add them together to find the final vector for the total resultant force. The total resultant moment, I'm sorry.